Any other suggestions? So to work out the perimeter of each shape. Now we probably have to do it when they're on the whole squares a bit, but to do that. Any other suggestions? Sorry?
Draw different polygons.
Draw different?
Polygons.
Oh, different polygons. Oh, yeah, with an area of 10, how many could you draw? Well, that's actually a really hard question, but it's actually an interesting question that we could actually get them to do. We're sort of going on to that a little bit later. Okay, so where might we go with this? Okay, this is probably a bit of a jump up, but you can see how we could ease into this a bit. But can you do this question? A block of land is described as an L shape. So it might be something like this. The area is 3,000 square metres. What might be the dimensions of the block of land? Don't worry about this second question for the minute. We're sort of going to hurry a little bit to get through. So who's got an answer that they'd like to talk about? Okay. Okay, so it's vaguely like that, where we have 30 squares. This isn't exactly the same shape that Eric described, but pretty close. And so once we've done that, and each square is 100, meaning 10 by 10, then we can actually then quite easily work out the dimensions to do that. Who did it a different way? Christopher?
I split it up in two, but I knew that I added up.
Okay, so it's really just breaking up the 3,000 into something and then draw them and then work out the dimensions. Yep, okay. Who did it a different way? All right, so this method was saying we're going to divide it into 4 parts and have 1 and 3. Each square then was going to be 750, and we then can work out the dimensions from the square, working out the length and the sides as the square root. That gives us that. Now, we did jump on that quite quickly, and I'm going to sort of hurry because there's a couple of things I want to do. Now, we might say how long might be the fence that goes all the way around the block, which sort of extends it another way. Then we might say draw some shapes with an area of 10,000 square metres where all the angles are right angles, but the shapes are not rectangles. Where's right down the perimeter? We might have actually asked this. On square dot paper, draw as many different parallelograms as you can with an area of 12 square centimetres, 12 square units. So, assuming they're the same parallelogram, meaning just flipped around and turned and stuff, can you quickly have a go at doing that, please? So stop doing that. What I guess I'm hoping you see is that both with the last question and this question, we've actually moved quite quickly from, in a sense, needing to know nothing to doing quite serious maths. Now, this, by the way, just if I can just show you, this is an example of one of them that's got a base of 1 and a height of 12. That one there, that my finger on. So that's an example of one. Over here, people wake up to the fact that you actually draw a rectangle to do that. Have I told you about the website called woodgear/eyeball? For the people who are interested in teaching geometry stuff, it's www.woodgear. Hang on. Yeah. www.woodgear.eyeball. Eyeball. E-Y-E-B-A-L-L. I think it might be .ca. It's a Canadian thing. But I think if you just put the first bit in and just search for it, and they just click on it, and it's a really sensational game. So it's more for teachers than for kids, even though it's really at the kids' level. It's the sort of thing that you could spend a couple of hours on playing. What year level? Oh, Woodgear. Woodgear, one word. Woodgear, that's the name of the company or something. .eyeball, and it's an eyeballing thing about parallelograms and in centres and right angles and so on. And I think just woodgear.eyeball and put that into Google and that'll find it. But if it's actually a Canadian, so it's going to have .ca at the end. That's off the point. Can I try and draw together what I was talking about here And then I've got one more comment that was a question, and then I'll just finish up. What I guess I'm saying is that there's a way of teaching maths to mixed ability classes. That you don't, there's a lot of, in a school that's in a sense lost the battle with the kids, I don't mind saying, well, okay, if there's a handful of kids who really want to study, put them in the same class. And, if you've really lost the battle, well, maybe you've got to do that. But if a school's going to get good, it seems to me you should be able to teach the whole of the kids in a way that actually gives them the experience of experiencing the whole of the class. And I leave that decision to you, but what I'm saying is that what I was saying before was you can actually set up open-ended tasks where you think about the enabling prompts and extending prompts, and you can deal with a mixed ability class. And likewise with this, even though I sort of jumped up quite quickly because I wanted you to see that you can start with a really simple idea and move it on to complicated ideas quite quickly, but the kids got the stuff to work with. It's not, even if they've missed school, they can still say, oh yeah, we're just going to use those ideas in this activity so we can actually get to do it. So I was just trying to present that.